Let's now take a look at what's called summation. A typical neuron in the central nervous system receives input from 1,000 to 10,000 synapses. So in other words, you can take one neuron and you don't have just one neuron communicating with one neuron, but rather that one neuron could have a whole bunch of neurons sending messages to it. Integration of these inputs involves summation of the postsynaptic potentials that form in the postsynaptic neuron. So here we have, in other words, this one neuron, and there's a whole bunch of neurons that are sending messages to it. Well, that postsynaptic neuron has to sort of make sense out of all of that information and decide whether or not it's going to continue to send a message on down the line. So what it's going to do is it's going to sum the postsynaptic potentials that are being generated by all of those neurons that are interacting with it. So summation is the process by which the graded potentials add together. In other words, the excitatory and the inhibitory postsynaptic potentials are going to add up, and it's kind of just like basic math. If there's more excitatory messages than inhibitory, then there will be a message that will continue on down the line. But you'll remember that in order for the message to be sent by this one postsynaptic neuron, the graded potentials have to add up to threshold. So the greater the summation of the excitatory postsynaptic potentials, the greater the chance that threshold will be reached. If several presynaptic end bulbs release their neurotransmitter at about the same time, the combined effect may generate a nerve impulse due to summation. Let's look at the two different kinds of summation. Summation can be either spatial or temporal. Here we have an illustration of spatial summation. Spatial summation involves summation of the effects of neurotransmitters released from several end bulbs onto one neuron. So here we have one postsynaptic neuron, and for sake of illustration, we have two presynaptic neurons. If presynaptic neuron number 1 sends a message, it doesn't get the postsynaptic potential all the way up to the threshold level. And the same can be said of presynaptic number 2. When it sends messages, it's not able to get the postsynaptic potential up to threshold. But if we send a message from both 1 and 2, or many different presynaptic neurons simultaneously, then all of the neurotransmitter messages that are being sent to this postsynaptic neuron might sum up and get that postsynaptic neuron potential up to threshold, in which case then it will go ahead and send an action potential. Temporal summation is the summation of effect of neurotransmitters released from 2 or more firings of the same end bulb in rapid succession onto a second neuron. So in this case we have only one presynaptic neuron that is sending a message to the postsynaptic neuron. If this one presynaptic neuron sends one message, it will cause the membrane potential in the postsynaptic neuron to go up but not reach threshold. And here we've done it again. But if this presynaptic neuron sends a whole series of messages very rapidly, one right after the other, then we might be able to get that postsynaptic potential to add up to the threshold level, resulting in the postsynaptic neuron sending an action potential.